All right, so I was out yesterday. Should have recorded this the first time I said it. But basically, we'll push everything back a day. So you guys online, I'll update the calendar. I'll link it to a new calendar, and everything will be pushed back a day up until basically Easter. Everything's moved back a day, and then when we come back from Easter, there's like 4 days of limits algebraically. We can do that in 3 days. Not a big deal. We'll put graphically back a day. That's a cleaner break for Easter as well. So we're fine. The big takeaway is test is Wednesday, not Tuesday. And I have another one of these printed and linked soon, so you'll be able to find that and be back on track. So sorry for the confusion. So it's almost like yesterday didn't happen. We'll do today as if, we'll just jump in with going over questions from worksheet 2, and then we'll do notes for day 3. Now, some of you had concerns with number 1, so let's look at number 1. And the concerns were, like, how accurate is my calculator, basically. I can't get my calculator to get it down to that accuracy. So let's plug number 1 in, and maybe we'll do, I think they're all kind of the same. So if we do number 1,
and then 2, the last.
we're pretty well set. All right, a project, I can't go straight to the calculator. Projectile is launched from a ground level, that's nice, h0 is 0. Launch angle, initial velocity. Okay, so x is, it's right up there, 88 cosine 60 times t, and y is 88 sine 60 times t, minus 16t squared. 88 cosine 60 times t, 88 sine 60 times t minus 16t squared. Okay. Graph it. It's probably not a good window because who knows, although it's not a terrible window, at least for x. So x needs to be like half as much of whatever it is now. So x was 0 to 450. So let's go 0 to 250. I'm going to go one at a time. I guess if you remember enough to change them both, that's fine. I need to increase y by a little bit. So let's see. We went from negative 10 to 80, so 125. We'll see if that works. Yeah, that's fine. Again, and not everyone's graph is going to be exactly right or exactly the same, because you're just going to play around until you get a window where you can see everything. Estimate the maximum height in feet obtained by the projectile. So trace. Now, this may be tricky because, let's see. Well, that one's pretty close. It gets to 90.75, and I don't know if it gets any higher than that, but that's the biggest, right? It's definitely not any lower than that, so I'm good with that one. Maximum range. Is this one where I'm going to run into trouble? Maybe. So I'm looking for, I'm at 5 and negative 2. That's not very close to each other. So somewhere between 206.8 and 211.2, but probably closer to 211.2. Okay, they're all in the range. So what can I do to get a better answer?
You can go to the table, then you can go to table set ask.
Okay, there's a couple answers to that. I can zoom. I could go to table. I don't know which one would be easier. I'm going to go zoom. Zoom in. Because then I just have to put my cursor reasonably close to that intersection down there. Now, I need to be careful because even that answer is probably not exactly right, because my T step is still so far apart that I can even tell by looking at it. It's just connecting points here. So I'm going to go change my T step to 0.01. I hope that doesn't take forever to graph. We'll see. It is taking forever to graph. Oh, what I could have done is changed the T min and T max so it's not graphing the whole thing. That's what's taking a while. So, do I wait for it?
Yes.
Or do I go change it? Which would be quicker?
Wait.
Oh, there we go. That wasn't bad. Oh, and now I still have to wait. Oh, that wasn't bad. So now I can go trace. Oh, this is going to take forever. Maybe I could, let's see.
Your cursor already over there and trace.
Where's the... If your cursor is close to it and you hit trace, it works better? Is that what...
At least mine does. Like if I'm on the outside side of it, really close to it, I hit trace.
So if I hit trace with my cursor close to it, you think that'll work? Although, this is all really close, so I may not even need to trace. I could just use the cursor and put the cursor close to it. So it's 209.4. I think that's my best answer. If I hit trace, oh, I'm still back at 0.47.
Or does yours go back?
It went way back to the beginning. So I'm going to scroll all the way over. I'm peeking ahead. This is going to help me answer the next question as well, though. Maybe table would have been better.
Mine just goes straight to it.
Table set. Table start at, I don't know, 4.7, 4.75, 4.74 maybe to make sure we're low enough. And change in table, we want it to be 0.01. Change that to auto. There we go. So let's find where our y value is smallest, or our y value is closest to 0. This might be the easy way to go. So y is 0 in between 4.76 and 4.77. Oh. So which one am I going to pick? I'm definitely going 209.5 for range. Table set is the way to go. You could go table set ask if you wanted to, I guess, type them in and see which one works the best. 4.75, 4.76, 4.77, 4.78. So which of those is closest to 0 would be 4.76.
How do you get to the task? Or how do you get to there?
You do second window.
Second window is table set, so you set up your table. And
0.1 as your
I've got it back.
so you can either do change in table 0.01 because that's the kind of the difference between times, or you can just say ask me and I'll tell you what times I want to type in. Either way. And then go to table. And it works the same way here. 4.76 is the closest to 0. A time of 4.76 gives you a y value closest to 0 and an x value of 209.5.
Did you do the last one on number 2?
Yes.
That one and then the third one.
So a lot of this is calculator, playing with the calculator. Number 2. Let's the last one on number 2. A projectile is launched from a height of 14 feet, angle 75, initial velocity 97. Okay, so all the equations we could type in.
Oh no, it's not like numbers. It's just
Which of the following can be used to determine how long it takes for the projectile to hit the ground? So when you're on the ground,
so do YT.
it would be y of t equals 0. Your y position is 0. Yeah, it's not any of the initial stuff.
You do the one right.
And then how long would it take for it to reach its maximum height? Let's say would be y or x of t.
X of no. Well, that would be. Wait, ask that again.
Maximum height. Like how long would it take to reach its maximum height would be x of t.
Well, its maximum height is going to be. Well, you want yt to be a max. You want the biggest yt. So you'd have to look at the graph or a table and see what gives you the biggest y value.
Okay.
So we couldn't really ask that question like this one is asked. Approximate the maximum range for this projectile. So we're looking for this x value over here. Alright, this will be the last one we do. So 97 cosine 75. 97 sine 75. So all you have to change is the initial velocity, initial height. Second insert, 14 plus, there we go. Uh-oh, I'm still on my zoomed in graph. That's not going to work. Window. I'm going to go back to point 1. 0 to 250, I don't know. Negative 20 to 200. Let's just see. Not a bad first guess. My t didn't go past the axis, so I may need to increase my t value by a little bit to make it go past, make sure I've landed. There we go. Do I want to change my window or am I fine? I think it's probably fine. The question was maximum range. Now those are all pretty close, so right now this is probably not good enough. So yeah, about 150, but about 150 isn't good enough. So do you want to table or do you want to zoom? Yeah, table. Okay, so what I need to know what t value that is though to kind of get in the ballpark for my table. Scroll way over there. Here we go. So about 6. So t is about 6. Okay, so now I'm going to go to table. This is going by 0.01, so this.
Ask.
Yeah, this can take forever. Let's change it to ask. Then table, and we said about 6. And we're searching for y to be 0. 6.1. Okay, well, we're in the ballpark here. 6.05. 6.01. So it's between 6 and 6.01. Is that, now am I accurate enough or not?
No.
Not really. 6.005? 6.002? That's pretty close. Is it close enough to... I bet it's A.
Yeah. I feel like that's going to be the hard part about this test is that it's going to be
Playing with the...
Well, you have to get to like as close as you possibly can.
You can't actually find it.
Yeah.
Because nothing else is close to...
Is there a way to ask for the y value instead? So like see like okay, let's get y value
Right.
0.
Like come over here and say, oh, I want to put 0. I want to type in 0 for y. It won't.
You can't do that.
Is there any way at all?
And you can't do it on the graph. Like second calc. If it was a y equals function of x, then you can do calc 0.
Mm-hmm.
But because it's a parametric, it won't work. So you got to do the zoom in, zoom out, play with the table. So we'll need to
Can you
be...
do dependent to ask?
Oh,
Can you? Second
that makes sense.
table set.
Y
Dependent
0.
ask.
There you go.
It won't let me hit 0. Oh, I can hit enter and it tells me what the. That's kind of dumb.
Wait,
Thanks a lot.
Wait, put ask on both.
Ask on both. Second table set. Ask on both. I think when ask dependent, it means hit enter to get the answer. I think is what it means. What did we say? 6.002 or something. And so it won't fill in until you hit enter.
That's dumb.
Which is kind of dumb. That's not really what ask means, right?
Okay.
So good thoughts. Ways you guys can program the next generation of calculators to get a.
I'm sure like the Tyler's calculator is probably good.